Welcome, everybody, to your Algebra 2 final exam review. Please make a note of this right here. Everyone must complete the review for a grade, even if you are exempt from the exam. So, no, you cannot get out of the review. I am so sorry. So this Edpuzzle is actually going to be skippable. I'm enabling skipping, so you don't have to watch every single question. In fact, I recommend you first do the ones that you know how to do, and then come back for help on the others. And I'm going to put one of those little question markers every 5 questions so that if you want to skip, it's a little easier to skip to the question you want. So I'm going to go through these a little quickly. So you may need to pause here and there, but hopefully this will be helpful. Number 1, the half-life of iodine-131 is 8 days. How long will it take for a sample with a mass of 200 grams to decay to 100 grams? So you are using the decay formula. So you have your ending amount, your initial amount. Here's your half for half-life. So it makes it decay by half every time. You have the amount of time that has passed, and you have the length of the half-life. So go ahead and plug in what you know. We know we start with 200 grams. We're trying to get to 100 grams. We don't know how long it's going to take. That's what we're trying to find out. So leave T. And then the length of the half-life is 8 days. And then you're going to do a reverse PEMDAS. So first, you want to add or subtract if you can, which we can't. There's nothing here that's added or subtracted. Then we want to multiply or divide, so I can divide by 200. So boom. So I get 1/2 equals 1/2 to the power of t over 8. Then I'm at my exponent step, so I want to convert this to logarithm form. That will help me get this t out of the exponent. So I have log base 0.5 of 0.5 equals t over 8. Multiply both sides by 8. And put that in your calculator. And so you get t equals 8 days. And here's what it looks like in the calculator. Just like that. So in fact, you'll notice that there's kind of a shortcut to this question. 8 days is the half-life, and if you check that out, there's half of it left. We started with 200, now we have 100, that's half of it, so that's exactly one half-life, which is 8 days. So you could also have done it that way. In fact, some of you did the test question in the Unit 9 test, you did it like that, kind of thought your way through it, which is pretty cool. And then how long would it take to decay to 50 grams? So same thing, I'm trying to get to 50 grams, I started with 200. Now, if you look at so half of 200 is 100, that was 8 days. Half of 100 is 50, that's 8 more days. So this should come out to 16 days. So you could kind of think of it that way, or you could go ahead and solve using reverse PEMDAS. Either way, your question on the test will be kind of like this. It's going to be a nice even amount of half-lives so that you could do it, you could kind of reason through it that way if you wanted. So guys, remember that this here is not an exponent. This is a subscript. In fact, I'm going to make that a little bit clearer the way I wrote that, because I keep seeing that a lot when you guys write logarithms. This is a subscript. I'm going to make it real obvious. That's a subscript. And then this here is just normal size. It's not a subscript. It's not an exponent. It's just like if there were a line right here that we were writing on, it'd be right on the line. So please don't make that an exponent. The exponent is t over 8. Okay, so, and then multiply both sides by 8 again. And I put that right here in my calculator, and I get t equals 16 days. All right, number 2. What is excluded from the domain and range of each of the following? If you don't remember your transformations very well, I would suggest graphing these. So these are all rational functions. So graph these. They're all rational functions. So when you're looking for exclusions, you're looking for asymptotes. So kind of like you have your graph kind of like that. So your vertical asymptote excludes the domain because it goes through the x-axis, and your horizontal asymptote excludes the range because it goes through the y-axis. So let's check out a few of those. Okay, now if you still have your Chromebook and you want to use Desmos, that's better because I just feel like it's easier to see, but a lot of you don't, you didn't pay your insurance, so you're going to have to use an Inspire. So I would recommend going to Menu and then View and then Grid and put a line grid on there for yourself so you can see a lot easier where the asymptotes are. So you can see the horizontal one is right about here, which is going to be 1, 2, 3, 4, 5, 6, 7, -7. Okay, so -7 is excluded from your range, so you can just kind of say y is not equal to -7. And then from your domain, you're going to look for the vertical asymptote, which is right about here at 1. And if you need to zoom out, you can. So you can see a little easier, but it's right about 1. So x is not equal to 1. And then do kind of similarly for each of these. So here's B. Now I've had to zoom out on B. So I've got 2, and notice these are numbered by 2s now. 2, 4, 6. So -6 is excluded from the domain. So x is not equal to -6. And then from my range, so it looks like, oh, well, let's try tracing. Kind of hard to tell on that one from the graph. And sometimes you want to skip to another x value. So it looks like it's kind of approaching 5. So that horizontal asymptote there is going to be at 5. So y is not equal to 5. So I've graphed C. Now I want to put my window back to normal. So I'm going to go Menu, Zoom Standard, number 5. And yeah, I probably shouldn't have done that actually. So zoom out again. Zoom there. Okay. So I can see 1, 2, 3. Vertical asymptote is about at 3. So x does not equal 3. And for my horizontal asymptote, I can see it right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So right about -11. By the way, if your function is written like these, here, right here, there's your x, your domain exclusion, and there's your range exclusion. So flip that sign, and that one stays the same. So that's just like your left, right, and your up, down. When it's written like this, you got to either remember the rules or you got to graph it. So I think most of you are going to want to graph it. And so here's D. Now I've zoomed out on D also. So it looks like I've got a horizontal asymptote. Let's see. Come on. It's not letting me grab it. Well, it should let you grab this and move it around. But it's not letting me. Oh well. So let's zoom out again. Okay, there we go. So it's numbering by 5. So 5, it's actually going to be at 16 there. So x is not equal to 16. The numbers on the test are going to be easier to see. These are just kind of tough a little bit. So 2, 4, 6, 8. So your horizontal asymptote is about at 8. So y is not going to be equal to 8. Number 3, an antibiotic is introduced into a colony of 15,000 bacteria during a lab experiment. The function below can be used to model the number of bacteria in the colony after m minutes. So the first thing, well, how much time is needed for the population to drop to 9,000? So we're going to plug, and we already got 15,000 in there. So we're going to plug that in just a minute. First thing, though, I want you to be aware of this n of m. So last year, this confused so many people. This is just like saying f of x, okay? It's not n times m. Don't worry about what n is. This is just like saying f of x, which is, again, just like saying y. So this is your y right here, and m is your x. So if you want to rewrite that this way, you can. Okay, so feel free to rewrite it that way. That's all it means. Now we want to know how much time it's going to take for the population to drop to 9,000. So 9,000 is my number of bacteria. M is minutes. So I'm looking for M or X. And 9,000 is going to go here for Y or for N. So 9,000 equals 15,000 times all this. I'm gonna go ahead and use M, but if you want to use X, it's not hurting anything. Okay, and now we got to solve this just like you solved number 1 with reverse PEMDAS. So there's nothing here I could add or subtract to get rid of, but there is something that's being multiplied right here, which means I can divide it away. So, and it's 3/5, which is 0.6. Okay, so there. And then when my variable is up here in the exponent, I need to turn this into a logarithm. So I have log base 0.637 of 0.6 equals m over 5. So then put that in your calculator. Let's see what we get. 1.13269 equals m over 5. And then just multiply by 5 to get rid of that denominator. Whoop, whoop. I'm in the parentheses now. So m equals 5.66344 minutes. Depending on the answer choices, you may need to round that off a little bit. But it'll either tell you or it'll be obvious what to round to. Okay, number 4, what is the domain of the absolute value function below? So remember, domain is your x values. So I'm looking at left to right. Now, when your line goes to the very end of the grid like that, remember that there's technically an arrow on both ends. So how far left can my graph go? Well, there's an arrow there, so it can go left forever. It can also go right forever. So that means I can have any value that I want for x. So my domain is going to be all real numbers. So you could see x is an element of all real numbers. You could just see all real numbers. You could see negative infinity to positive infinity. So just remember those different ways to write it. Number 5, what is the solution of that equation? So it's a square root equation, so it's a reverse PEMDAS problem. So is there anything that I could add or subtract? Yes. Now this, when there's like a negative number in front of your grouping symbol or your parentheses, that tends to confuse people. So you got to think about, I need to cancel a negative 6. It's a negative 6 that's added to the rest of the equation. It is not multiplied or divided. So it's definitely this step right here. How can I cancel a negative 6? It's like, how can I cancel a debt of $6? Well, I need positive $6, right? So I'm going to add 6 to cancel that. Negative 6 plus 6 comes out to 0. So that cancels. So then I have the square root of 5x plus 4 equals 10. So that's done. There's nothing I can multiply or divide that's not in that square root, so I can't do this right now. And now I have my exponent step. So remember, the square root is an exponent. It's an exponent of 1/2. And some of you liked writing it. When we did this unit, some of you preferred to write it this way. So it's just really up to you whether you want to leave it like this or you want to write it like that. Either way, you need an exponent of 2 to cancel that out. So you're going to square both sides. Let me do this. Okay, so either way, square root cancels the square. 1/2 exponent cancels the square. It's the same thing. And then you end up with 5x plus 4 equals 100. Either way. Finished my exponent step. Now I'm in the parentheses or the grouping symbol. So I start back at the bottom. Can I add or subtract anything? Well, I sure can. I can subtract 4. There we go. So I have 5x equals 96. And then finally divide by 5. And that gives me 19.2. Now you do want to go back and check. So plug it back in and make sure it's not extraneous. So I'm going to type -6 plus the square root of 5 times 19.2 plus 4. And make sure you get 4, which you do. So it is an actual solution. It's not extraneous. Yay. Number 6, Shauna can pour a large concrete driveway in 2 hours. Dan can pour the same driveway in 8 hours. Find out how long it would take if they work together. So this is this kind of problem where I have Shauna plus Dan. So Shauna's work plus Dan's work, that looks funny, equals the work they do together or total. I can't spell today. How sad is that? There. So Shauna can do one driveway in 2 hours. Dan can do the same driveway in 8 hours. And I want to know what they can do together. So hopefully you remember doing this February or so, I believe it was. So when I add fractions, I need a common denominator, or I could turn them into decimals too. That would work. I'm going to go ahead and get a common denominator. So my common denominator is actually 8 here. So 4, multiply these by 4, that I can leave alone. So 1/2 is the same as 4/8 plus 1/8 equals 1 over x. 4/8 plus 1/8 is 5/8 equals 1 over x. And I can cross multiply. So 5x equals 8. Divide by 5. And get x equals 1.6 hours. Number 7, what exponential statement would be equivalent to this log? And hint, that just means convert it to exponential form, that's all. So remember that you have log with your base, and then you have whatever you have in here, your argument. And that equals your exponent. So then when you convert it, you have the base to whatever your exponent was equals your argument. So you want it to look like this. So I'm going to take my base, which is 2, and then find my exponent, which is going to be on the other side, so 3, and then equals my argument, x minus 5. Now, it doesn't say solve, so you don't have to figure out the value of x. That's it. You're done. Number 8, simplify. 5 over x minus 1 over x plus 2. Fractions again, so we need a common denominator. So remember, when you have fractions with x or with x's in them, the easiest way to find the common denominator is to multiply each fraction by whatever the other denominator is. So I'm just going to actually rewrite it first so I have some space. So I'm going to multiply the first fraction by x plus 2 over x plus 2. And I'm going to multiply my second fraction by x over x. And then I'm going to combine. So I'm going to go ahead and multiply actually before I combine. So 5 times x is 5x. 2 times 5 is 10. And then minus. And then 1 times x is just x. And then x times x is x squared. 2 times x is 2x. And then that denominator stays the same because you always keep the same denominator once they're common. So then I just need to combine like terms on top, which I have 5 x's and I'm taking away an x, so that leaves me with 4x plus 10 over x squared plus 2x. And these terms do not all have a factor in common, so that means I'm finished. Number 9, solve for x, round to the nearest hundredth if necessary. So I'm going to figure out the value of x using reverse PEMDAS. So I want to start by adding or subtracting. And in this case, I can subtract 4 from both sides. And here's where a lot of kids will make a mistake. They'll try to do the reciprocal exponent next and forget this guy right here. Don't make him sad by forgetting him, please. The exponent does not apply to the 5. The exponent applies only to the x. So you got to cancel the 5 first. So you got to divide by 5 next. Then you can do your reciprocal exponent. So I'm actually going to rewrite it so I have some room. So I never leave myself room on these. So the reciprocal of 3 over 2 is 2/3. Make sure you do that on both sides. 2/3 and 3 over 2 cancel each other out because they're reciprocals, and you get x equals 2.08. And then it goes 0.008, but it did say round to the nearest hundredth, so I don't need those. X equals 2.08. Number 10, give the equation for all vertical asymptotes of this graph. Now, if it's given to you factored like this, all you have to do is flip these two signs and you got it. That's it. It would be x equals -5 and x equals 1, but let's just graph it. Let's check, because I know a lot of you are going to want to graph it. So here's my graph, and you can tell there's a vertical asymptote here at -5, so 1, 2, 3, 4, 5. Oops. And at +1. So -5, +1, and they are x equals lines because they go straight through the x-axis. So either way you do it, that's all I got to do. Both of those. Number 11, which values are excluded from the domain of the rational function to the left? This is the same thing as vertical asymptote, which are conveniently given for you. There's your x values, there's the domain. So there's one at +2 and one at -2. So x does not equal -2, and x does not equal +2. And that's it. Number 12, evaluate log base 2 of 83 equals x. So evaluate means put in your calculator. There's nothing to solve. There's no reverse PEMDAS. There's nothing else to do. Just put it in your calculator, honestly. So just plug him in. Log base 2 of 83. And I get this 6.37504. Bam, done. 13. I want to solve this and see if there's an extraneous solution. If so, what is it? So remember when we did square root functions, they kind of look like this. This is going to be shifted to the left. So there's your square root function. And then I've got this linear function that kind of goes like that, roughly. And that's your actual solution right here. But then you got so that's a sideways parabola, right? So you've got this other portion that doesn't show up because it's not a function if that portion is there. But there would be another intersection right there. And that's your extraneous solution. So remember, an extraneous solution is a solution that might appear to be there, but it's really not a true solution. So most of you would want to do this by graphing. So I'm going to go ahead and put this in my calculator. Here's what that looks like. Actually, it intersects on the y-axis, which is not what I drew. to scale. Oops. So it's not the best picture, but it at least gives you an idea of what to look for. So here's my true solution. So my true solution is x equals 0. So you can kind of see that. Let's go trace, graph trace. So right there's my solution, x equals 0. So to get the extraneous one, I need that bottom half. So you're just going to press, tab, and then you're going to type this with a negative sign in front, because that's your vertical reflection, right? That's going to turn it upside down. 2x plus 16. And there's my extraneous solution right there. See, that matches that kind of, the location of it, the general kind of position. So let's trace again. Go to the left. You know what? You can also guess. So I'm going to guess 1, 2, 3, 4, 5, 6. I'm going to type in -6. Let's just guess. Oh, right. I need to switch graphs. So to switch graphs, you press up or down. Okay, so it looks like right at -6 is where that solution is. The extraneous solution. So extraneous, x equals -6. So there's your true solution and your extraneous solution. So you just really got to remember this vocab word right there. Or make an anchor chart. That'd be a good idea. Some of you need extra credit anyway. Why not? 14. Find the inverse function of f of x equals 2 to the power of x minus 9. So remember, this means switch x and y. So I've got my function. I'm just going to rewrite it. Now remember, f of x is really y. Okay, then I want to switch x and y. So I'm going to have x equals 2 to the power of y minus 9. And I need to get the y by itself again. So I can use reverse PEMDAS. Can I add or subtract anything to get the y alone? Well, yes, I can. I can add 9 to both sides. That'll cancel that out. So x plus 9, please do not say 9x. Please do not say 10x. I'm not adding 9 x's to this side. I'm just adding the number 9. I don't know what x is. So I can't combine those. They're not like terms. It's just x plus 9 equals 2 to the power of y. Multiply and divide, there's nothing. There's actually no multiplication or division in this problem at all. Unless you expand the exponent, which we're not going to do because it's a variable. Then I'm at my exponent step. So remember, when my variable is up there in the exponent, I got to use a log. So I have log base 2 of x plus 9 equals y. And then my y is by itself, and I'm done. "15, give the transformations for each function below." So remember, you got your left, right, your up, down, your stretches, your reflections. There's not a compression on here, but that's okay. So I've got left 7, down 14. You guys were pretty good at this. I think you'll be okay. And then, this, I don't think it's on the test. That's going to be a horizontal compression. Because it is inside the symbol, right? Right inside there. And then up 10. And then I have 2 vertical stretch by 2. I've got a left 5. I've got a vertical reflection, left 12. These are all lefts. So think, make sure you know what would make it go right instead of left, because these are all left. And then down 27. Number 16, solve natural log of 6x minus 2 minus the natural log of 2 equals the natural log of 8. Remember, ln of whatever is just log base e of whatever. So a lot of people get thrown off by the ln, or they call it in, or they think it's 1n. No, it's ln. It's just a log. So it's the same as every other log. So since I'm taking log minus log, I've got to use quotient rule here to combine them. So I have the natural log, so ln log base e, of, and then remember to use quotient rule, you're going to take the first one and then put it over the second argument. So first argument divided by second argument, and then equals whatever's over here, ln of 8. Now the nice thing about this particular problem is that now I've got a log with the same base, so they're both log base e. I've got one on each side, so I can just cancel them out. And I have 6x minus 2 over 2 equals 8. And that's just a reverse PEMDAS problem, which makes it super easy. So I do have addition and subtraction, but it's up here in the numerator, so I can't do it yet. It's kind of like as if that were in parentheses. So first I have to get rid of that 2. So I'm going to multiply both sides by 2. So 6x minus 2 equals 16. So now I'm in the parentheses, so I can add 2 to both sides. And then I have 6 times x equals 18, so just divide by 6, and then x equals 3. And you do want to double check, make sure you don't get an error message, so remember to plug that back in there. Let's actually do it. So here's what I typed in the calculator. Now you could double check and make sure that it equals that side as well, but all I'm really looking for is making sure it's not extraneous. I just don't want an error message. If you wanted to check the whole thing, then you also put in the right side. So ln of 8, and just make sure it roughly matches, which it does. Go us. So we got it. Yay. 17, find a regression equation to model this set of data. So this is that list in spreadsheets that we did last week, or 2 weeks ago, depending when you're watching this video. So I'm going to do that real quick. I've entered the data in list in spreadsheets, and again, make sure you get off that last cell after you enter the last number, and then add a page, data and statistics, place your variables. So I can see it's quadratic. It is not going to be linear. It's going to be quadratic. Did it say that? No, it didn't. But it's going to be quadratic. It's an upside down U. So menu, analyze, regression, show quadratic. Make sure you pick 4 quadratic and not 6 quartic. That's different. And then write down your equation. And sometimes you will have to scoot it over. Now this is going to be a multiple choice question, but still want to make sure you scoot it over so you see the whole number. There. There's your long equation. Yay. Okay, 18. Solve this rational equation. Now you could try graphing each side separately and solve it that way, especially if you've got Desmos. But we're going to go ahead and solve it by hand, which means I need a common denominator. So just like number 8, if you did number 8 with me, we're going to get a common denominator by multiplying by whatever the other denominator is. So I'm going to multiply this first fraction. Let me get rid of that. This first fraction I'm going to multiply by 2 over 2. Same with this one. And then this one's going to be times x minus 7 over x minus 7. So then my denominators are all the same. Well, I'm going to multiply the top. So 2 times x is 2x over 2x minus 7 equals, so 1 times x is x, 1 times negative 7 is negative 7, and then 2x minus 7, and then plus, and then 2 times 7 is 14 over 2 times x minus 7. Now, at this point, my denominators are all going to cancel out. I do want to go back and check them at the end and make sure I don't get no solution, but for now, I can ignore the denominators because they're going to cancel each other out anyway. So I have 2x equals x minus 7 plus 14. And go ahead and combine the like terms right now because they're just sitting right there. Why not? So negative 7 plus 14 is just 7. Okay, then let me rewrite what I got. Now I've got x's on both sides, so I need to cancel the x from one side. I'm going to go ahead and cancel this one here. So to cancel an x, I can subtract it. So 2x minus one of the x's is just x equals 7, so x equals 7. Now you do want to plug back in. Plug it back in. Watch what happens. So I'm just going to plug it into one side, in fact. So 7, I'll give a fraction, 7 over, and then x, we got 7 for it. So 7 minus 7. Anybody see what's going to happen right there? That's right, my denominator is going to be 0. Undefined! So this is not really a solution. I got undefined here. If I plug 7 into that denominator, the denominator is going to be 0. So this is really no solution, unfortunately. Nope. 19. We're going to solve this equation using reverse PEMDAS. So I can subtract 15. And then, again, I didn't leave myself any room. I always do that with these rational exponents. So there's nothing to multiply or divide except what's in the parentheses, so I can't get to it yet. So now I'm at my exponent step, which means I use the reciprocal. So 3 over 2, the reciprocal is 2/3. Those cancel each other out. So 8x minus 1 equals 9.22087 approximately. Then I can add 1 to both sides. So 8x equals 10.22087 and divide by 8. So I get 1.15261. Normally you want to plug it in, make sure you don't get no solution again, but this isn't gonna 8 times this and you're only subtracting 1, that's gonna be fine. Number 20, a lot like number 17, go to your list and spreadsheet page. So there's all my data in the list. Make sure you get off the last number you typed. Add a data and statistics page. Add your x and y, and it should be quadratic. And annual menu, analyze regression. Make sure you choose quadratic and not quartic. Okay, quartic is to the 4th power. I want to the 2nd power. And then write down your equation. And there you got it. Oh, that looks really funny. That's a 5-3, by the way. If you're doing this at home and you don't have an Inspire. All right, number 21. The pressure of a gas varies inversely with its volume. Use the formula P equals 659 over V to find out the pressure in milliliters of mercury is what that means. Millimeters of mercury. It's a measure of pressure. And it's a U. You don't really need to know that for the problem. It's just a bit of information. When the volume is 47 liters. So they tell us the volume. We're looking for the pressure. All you got to do is take 47 and put it in for volume. So this is a rational function, but you don't really have to do anything with rational functions to figure this out. Just plug in 47. So P equals 659 divided by 47, and just put that in your calculator. Pressure equals 14.0213 millimeters of mercury. That's it. Easy enough. 22, list the transformations. So we got another transformation one. So I got vertical reflection, left 4. This is a horizontal reflection, because it's inside with the X. Down 1. Now this, okay, so this is where people get confused. This is a number between 0 and 1. So 0 is less than 2/3, is less than 1. That means it's a vertical compression. So you see a fraction in front like that, it's going to be a compression, or a decimal like 0.5. And this right here is another left 1, up 21. Then this one we've got a vertical reflection. The 2 is a vertical stretch. That's commonly forgotten. So the negative and the 2 are separate. The negative reflects it, but the 2 stretches it and makes it twice as tall as it would have been originally. So you got both. And then right 1. And then we got vertical compression here because it's 0.5, so it's half as tall, so it's getting squished. Think of it that way. It's a compression. And then up 9. 23, give the domain and range of each function below. If you don't remember these, I would suggest graphing them all. Here's A. You may want to add a grid. View, grid, line grid. Makes it a little easier to see sometimes. So my domain, so my x's, I want to go left to right. What's the leftmost I can go on this graph? Well, on the screen it's -10, but of course the graph keeps going that way. It's not going to end just because my screen ends. It would really keep going. So I'm all the way to -infinity there. And then on the right, it doesn't just end at like 1.5. It keeps going. It's going to slant, but it's going to keep getting slowly more to the right. So my domain is going to be all real numbers. My range, on the other hand, it's exponential function, so I've got a horizontal asymptote here. That means my graph does not go below this number, which is -2. So my y values cannot be less than -2. However, they can keep going up, so my y values can get bigger. So I might say y is greater than -2, or I could say -2 to infinity. And that's not an ordered pair, it's just interval notation. So you might say it either way. This B is a quadratic, and I know some of you are going to call me over saying, Miss, it didn't show up. Well, that's because it went up 13. And my graph only goes to 6.67, so you're going to have to... Now it's letting me move it. An earlier problem didn't want to let me move it. You're going to have to move it so you can see it, either that or zoom out. So quadratics always have a domain of all real numbers, unless you're talking about some word problem context, but we're not. And the range you'll see is, so 13 is the lowest that my y values can go, but they can keep going up forever. So I want to say y is greater than or equal to 13. This has an equal to where the last one does not. This was an asymptote. This has an actual point. And then for interval notation, I can go from 13 to infinity. So either way you want to see it. Remember, the bracket is for if you are including the number, parentheses if you are not including the number. See, and again, some of you are going to say, Miss, I can barely see the graph. And that's because it moved down 7. That's down 7, so you're going to have to move your window. It's just how it is. Sorry. That's logarithmic. So, of course, logarithmic functions have a range of all real numbers. Domain we'll check in a second. Range, we know it's all real numbers. Now you got to find your vertical asymptote, which is at -1. So the furthest left I can go on this graph is -1, but I can keep going to the right. So my x's are all greater than -1. So x is greater than -1, or you might see -1 to infinity, kind of like that one was for the range. Because here's D, and I just didn't move my window from what I had it for C. So anyway, that works. So square root functions have either a beginning point or an end point. So first let's look at my x's. What's the leftmost I can go? Well, my leftmost point on this graph is at -2 for the x value. So my domain is, you can either say -2 to infinity, or you can say x is greater than or equal to -2. For the range, the smallest y value. So let's see, -1, -2, out of the way, -3, -4, -5. So I can go -5 to infinity, or I can go y is greater than or equal to -5, either way. 24, what is the solution of log of x plus 1 equals log of -3x plus 13? So notice I've got one log on each side. I don't have to use product rule. I don't have to use quotient rule. I don't have to use power rule. Don't even have to do reverse PEMDAS just yet. First, I can cancel both logs out. And then I get x plus 1 equals -3x plus 13. And I got to cancel the x's either from the right or from the left. And it really doesn't matter, but I'm going to go ahead and cancel this one because then my x's will be positive, and I kind of like it like that. So a -3x is going to be canceled by adding 3x. So x plus 3x is 4x plus 1 equals 13. And then I can subtract 1 from both sides. Yeah. So 4x equals 12, and then divide by 4. X equals 3. And then you do want to make sure that you're not going to get no solution there, so plug it back in and see. I went ahead and plugged it into the whole thing, and it came out true. There's no solution, so we're good to go. Finally, number 25, what is the solution to this equation? Now notice where the x is again. When your x is in the exponent, you're going to have to use a log to solve this. So first, though, we got reverse PEMDAS. So can you add or subtract anything? Well, sure. Add 8 to both sides. 2 to the power of x plus 9 equals 24. Now, I don't have anything to multiply or divide in this problem. So I'm on my exponent step, which means I need to write it as a log. So remember, I have base, and then I have my exponent equals my argument. And to convert that, that's going to give me log base whatever of my argument equals my exponent. Okay, so make sure everything goes in the right spot. So my base becomes a subscript. So log base 2. And then this part, the argument, is the one that initially is by itself, and then it goes in parentheses. So 24 equals, and then the exponent ends up by itself, which is the whole point. That's why we're doing this. That's why we do a log. So put this in the calculator. And you get 4.58496 equals x plus 9, and then just subtract 9 from both sides. And you get x equals -4.41504.